Good morning, good afternoon, good evening. Thank you for joining today's webinar, where we'll focus on innovations in JDK 15 and beyond. I'd like to introduce myself. My name is Sharath Chander. I'm part of the Java platform group here at Oracle, a longtime member of the Java community. We have a lot to cover today. I have a co-presenter, Aurelio Garcia Ribeiro, who will come online very shortly to join me in giving today's presentation. For sure, if you have questions, you're more than welcome to email me or follow me on Twitter, and we can extend the conversation after today's webinar. Some opening housekeeping. Today's session is scheduled for 30 minutes. We might go a little bit over, so hopefully you'll stay online as long as we keep going. We encourage you to submit your questions after the presentation is over and use the Q&A widget to submit your questions. And also, today's presentation is being recorded. All of you will get a replay link for today's recording, as well as an opportunity to see some of the webinars that we've done in the past for you to watch on demand. Now, I can't start without first saying happy birthday. 2020 is an auspicious year for Java. We all know that we're celebrating 25 years of innovation, and whether you're using Java for 1 year or 5 years, 10 years, or in some cases 20 years plus like myself, it is truly amazing to see how Java has shaped the world we live in. It powers businesses and industries. It's created greater innovation opportunities for you as developers, and it's extended all of our careers in ways we've never imagined before. And all of that's possible because here at Oracle, we take two things very seriously. Number one, ecosystem stewardship. You are important to us. We want to ensure we continue to invest in programs that allow you to further your knowledge and experience with Java, programs that allow you to connect with other developers to collaborate, and programs that allow you to understand new use cases and best practices as Java evolves for the future. Now, part of that stewardship of the ecosystem isn't just former programs, but new ones as well. Now, as we celebrate 25 years of Java, we've launched the Our World Moved by Java campaign. This campaign we foresee going on for a calendar year, if not longer. We launched this in May. You can come to our portal where we have imageries of the Java mascot available for you. We have personal stories from developers around the world in terms of how Java has influenced their career. We have third-party research that shows how Java will continue to stay vibrant. We even have a Java timeline that calls out many of the milestones in the history of Java that you can explore. And it's a great place to also come and visit to understand what other activities we'll be moving forward with. We've also recently launched the Inside.java program. This is our opportunity to show and update you on all of the various updates and news that comes from the Java team. You get this in a digestible format. You can RSS feed this to yourself. And it's a great way to understand the sort of innovation that's happening around the language and the platform. Also, we've recently launched a podcast series inside of Inside.java. We have many episodes that have been recorded and many more that are scheduled. It's your opportunity to hear from the engineering experts in terms of what design decisions are being made, what advances are being invested in, and the status of many of the projects we are investing in. Now, moving forward from a technology standpoint, as the technology leaders around Java, what does the next 25 years look like? Now, the way we get there is actually relying on our previous virtues. These are virtues that have made Java successful for 25 years, and we want to embrace these same virtues as we evolve the language and the platform for the next 25 years. We consider these our North Star in terms of guiding our direction and the investments we make from a strategic technical standpoint. Now, those virtues have allowed Java to be the #1 programming language amongst the sea of choices you have. There are many options you have out there, and it's also important to recognize and celebrate that Java continues to be the #1 language out there for you. It continues to offer uniqueness and relevance as modern application development landscapes change. And we want to ensure the investments you've made in the past have value in the future. That's why we take backwards compatibility so seriously. And as we evolve moving forward, we want to rely on the enhancements we've made in the past. Things like generics in Java 5, lambdas in Java 8, or even modularity in Java 9. These past investments help us guide and shape and frame for the future. Now, A lot of people ask me, where does the magic happen? Well, there is no secret trick or hidden cards that kind of guide us. We do all of the innovation in the OpenJDK project. It allows us to openly and transparently develop. It's a place where you can participate and give us feedback as we make the enhancements for the future. So we encourage you to come and visit us at openjdk.java.net. Now, from the OpenJDK project, we create 2 functionally equivalent releases for you because choice matters. We offer an open source license under Oracle OpenJDK, which is more free than ever before, which allows you to access and take advantage of new features with minimal friction. We also offer Oracle JDK. If you need enterprise grade support or cannot use an open source license in your environment, we then encourage you to use Oracle OpenJDK, as well as Oracle JDK, depending on what your needs are. Now, in terms of innovation, all of this innovation happens at the OpenJDK project. Now, we invest a lot of time in many projects that are advancing the language as well as advancing the platform. Now, a lot of the projects listed here are where we spend a lot of our time. Each one is trying to address a known pain point, an area of opportunity, or in some cases, improvements on past work. Things like taking advantage of new hardware architectures, simplifying the Java language syntax so it becomes more approachable and less verbose, focusing on areas like startup time, or even optimizing code and data to address new areas like machine learning. Now, these projects listed here, as well as the many other projects at OpenJDK, these aren't large, massive features or projects. Instead, what we try to do is incrementally make improvements and then deliver that new functionality in a pace such that you can pick it up and start implementing it sooner. And to kind of reinforce something that is sometimes missed, back in 2017, we announced that we were going to ship Java at a much more predictable and rapid pace. We now release Java at a 6-month increment, which takes the guessing game out of when will Java be available for me. And to kind of illustrate this, so let's just take a look at what we did in the past. Between Java 8 and Java 9, over 3 years of time passed, and these releases were oftentimes disruptive. A lot of features to account for, significant gap between releases, and it made it a bit of a challenge for you as a developer and as an enterprise to pick up. What we've done since then is introduce Java such that you get it on a 6-month release. We release Java in September and March of every year. As you can see here, using JEPs as our measure, Java enhancements proposals, we are giving you innovation at a much more incremental pace, at a much more rapid pace. So this is not about throughput. This is about reducing latency and giving you access to features once they're done. And so with that, I'd like to hand it over to Aurelia, who'll kind of explore some of the features in Java 15 that are important to you. So Aurelia, I'd like to have you come on board.
Thank you, Sharad. Can you hear me?
We can hear you just fine.
Okay, and then let me know when you can see my slides.
We can see Aurelio.
Fantastic. So my name is Aurelio Garcia Ribeiro. I'm a Senior Director of Product Management in the Java Platform Group at Oracle. I joined Oracle through the Sun acquisition in 2010. And before that, I was part of the Java IC Product Management team, which I joined in 2008. In the next 30 minutes or so, I will give you an overview of the most important features introduced with JDK 15 and point you to the right place for learning more about this release. We have, as usual, a mix of enhancements to the language, the libraries, and the JVM, as well as some housekeeping. There is also a good set of preview and incubator features being considered for future releases available in JDK 15 so that we can gather feedback before they're finalized. I will give you a quick overview of these JEPs now. If you would like to learn more about any of them, the best source of information is usually the text of the JEP itself in OpenJDK. So just search for that in your favorite search engine. There are many more smaller changes, performance, and stability updates that you can read about in the release documentation. JEP 361, it aims to deliver a platform-independent implementation of ADDSA for the Sun EC provider that will perform as good as the existing native C implementation. ADDSA was designed to be resistant to commonly used side channel attack vectors, such as those that exploit timing and speculative execution from branching. DSA's timing is the same for all secrets. It does not have branch operations that depend on secret data. Like other signature schemes, DSA uses a secret value unique to each signature. In DSA, this secret value is generated randomly. So if the random generator is broken, the signature can leak the private key. DSA uses a hash of a part of the private key, so no random number generator is used to make the signature, which avoids this risk. This JEP does not propose the integration of DSA with TLS 1.3. That work will be completed in a follow-up enhancement. With JDK 15, we add text blocks to the Java SE standards. They were previewed in JDK 13 and 14. Feedback from 14 suggested that they were ready without further changes. Text blocks are multi-line string literals that can be represented in code without having to deal with most escape sequences and clunky concatenations. So for example, imagine that you want to assign some HTML into a string in your program. Before text blocks, we had to process strings using a new line escape sequence and concatenating multiple strings. Now, manually processing these strings is error prone, and the resulting code is hard to read. This could be even worse if it happens to contain a few double quotes, which we would have to escape. Now, wouldn't it be nice if we could just cut and paste the text unmodified right into our editor? Here we see the result of replacing the traditional string with a text block. It uses the same set of escape sequences, but a different delimiter, 3 double quotes, and can now span multiple lines. Now, moving to multiple lines leaves us with a dilemma. We normally want to indent the text block along with our code, but we probably don't want that incidental indentation to show up in the string. So we use heuristics to determine which indentation is part of the string and which is accidental, and we trim off accidental indentation. In this example, the gray dots indicate which left indentation was deemed accidental and removed. The algorithm will also trim spaces to the right of the last non-white character in each line. Thanks to the feedback that we received on JDK 13, 2 new escape sequences were added to text blocks. A backslash will allow you, followed by a line terminator, explicitly suppresses the new line character. This is useful if you want to use a multi-line string for improving readability of your code, but your intention is to have a long single line string. We also added a new escape sequence for dealing with trailing white spaces. Using \s, you can let the compiler know that you want some of those trailing spaces preserved. In this example, we will have exactly 5 character long lines. So the \s preserves the extra spaces. JDK 11 introduced Z or set garbage collector as an experimental feature for Linux. With JDK 14, we added it still as experimental to Windows and Mac. With JDK 15, setGZ is no longer experimental. It's now fully supported, no longer requires unlock experimental VM option flags. To get an idea of how much shorter the garbage collection pause times in setGZ are when compared to earlier garbage collectors, we compared the pause times using the same benchmark of parallel G1 and Z. So this chart shows the pause times for average, percentile, and max values. Although the CGC garbage collections are very small, they're not quite 0. They're just so much smaller than the other ones that they appear to be. But if we look more closely, we will see that they have an average pause time of 100. The G1 and parallel have hundreds of milliseconds. CGC, on the other hand, has under a millisecond. And the max pause time is under 2 milliseconds. There's, of course, some trade-off. On some workloads, you will see a few percentage points of throughput benefit for G1 over C. And for very small heaps, like a few 100 megabytes, G1 is also likely to do better. So we don't have a one-size-fits-all GC, but we continue working on it. JDK 15 also removes the experimental flag from the Shenandoah garbage collector. Now, it's not always about just bringing new features. It's also about making sure that previous features and libraries are kept current. With JDK 15, we've revamped the datagram socket API. The previous implementation dates back to JDK 11. It's a mix of legacy Java and C code, and it's very hard to maintain. Multicast socket is particularly problematic since it dates back to when IPv6 was still being developed. The new implementation is simpler, easier to maintain, and will be easy to adapt to work with virtual threads currently being explored in Project Loom. Sealed classes and interfaces restrict which other classes or interfaces may extend or implement them. Okay. Java developers are familiar with the idea of restricting the set of subclasses because it often comes up in API design. The language provides limited tools in this area. Either make a class final, so it has 0 subclasses, or make the class and its constructor private, package private, so it can only have subclasses in the same package. The package private approach is useless when the goal is modeling alternatives, since user code cannot access the key abstraction, the superclass. So it is not possible to allow users to access the superclass without also allowing them to extend it. What we really wanted was a superclass to be widely accessible, but not widely extensible. So sealed classes. In JDK 15, this is still a preview feature, okay? So preview features must be enabled by using a command line at compile time. They must also be enabled at runtime or you will get an error. The idea of preview features is that we gather feedback before we finalize them into the language. Let's look at an example. A class is sealed by applying the sealed modifier to its declaration. Then, after any extends and implements clauses, the permits clause specifies the classes that are permitted to extend the sealed class. Now, a sealed class imposes 3 constraints on its permitted subclasses. The sealed class and its permitted subclasses must belong to the same module, or even unnamed module, the same package. Every permitted subclass must directly extend the sealed class, and every permitted subclass must choose a modifier to describe how it continues the sealing initiated by the superclass. You could have something be final and allow no more subclassing. It could in turn be sealed, which means that it will have its own set of permitted subclasses. Or it could be non-sealed. A sealed class cannot prevent its permitted subclasses from doing this. One and only one of the modifiers must be used by each permitted subclass. Java Lang class will get 2 new methods so that code using reflection will be able to determine if a class or interface is sealed, and if so, to get a list of the permitted subclasses. Pattern matching, for instance, is back for a second preview, and it has already been targeted to JDK 16. So it should be added to the language next March when JDK 16 is released. Pattern matching allows us to express conditional extractions of components from objects in a more concise and safe manner. Let us see an example. We've seen or written code like this, right? We have an object which could hold different types, and we want to do something if it happens to be a particular type. In this simple statement, we have 3 things going on. We have to test to see if the object is a string. If it's a string, we have to declare a new string variable so that we can cast the object. And then we cast the object into the new variable so we can treat it like a string. Right? Using pattern matching, we can reduce the code into a single line that does all of these 3 things. The variable is only created if the object is a string. If so, the object is automatically casted into the variable, and the variable is in scope only inside the brackets of that if statement. If there was an else statement on the conditional, the new variable would not be in scope in the else part. Even with more advanced conditionals, the scope of the variable behaves as you would expect. For example, if we use and in a conditional, since the second part of the statement is only evaluated if the first part is true, S is in scope for the second part of the conditional and in the brackets for that branch. If we were using or, however, the second part of the expression would only be evaluated if the first part is false. If the first part is false, then the variable is not in scope, and you cannot use it in the second part or inside the brackets. One of the features that received the most attention on JDK 14 was record types. JDK 15 brings records back for a second preview with a few refinements, and records are also now targeted to be added to the language with JDK 16. Records save developers the need to deal with some of the boilerplate that one has to create when attempting to use a class which simply aggregates immutable data. Take, for example, a simple class to express a coordinate. We just want to pass around an immutable pair of integers, x and y. But you need a constructor to set the values. And we want all the classes to implement an equals and a hash code. And we also like to see the values if we use toString. And we want to be able to access those values. So we need some methods to read them. Now the accessors are not using the traditional getX and getY, but just the name of the fields. Now, all of this extra code could be auto-generated by an IDE. So writing it is not a big deal, but it doesn't help you when trying to read the code and understand what this class is for. We have to review all of this auto-generated code before we can be sure that this is a plain vanilla data class and that there's nothing but ceremony behind these methods. What if we could let Java handle all of this? Instead of saying class, we say record. And the compiler can make sure that our record type gets all of those required methods without us having to include them in our code. Now, if for some reason some of those methods weren't just boilerplate, let's say you need a constructor so you can do some validation in the incoming data, well, you just need to implement the constructor and the compiler will provide all of the other ones. This way, whatever is written is indeed required. And when reading the code, you only see things that are necessary, no boilerplate. In some future JDK release, we plan to make it so that you can use pattern matching on records. Now, many language implementations built on the JVM rely upon dynamic class generation. For example, Java-C does not translate a Lambda expression into a dedicated class file at compile time, but rather emits bytecode that dynamically generates and instantiates a class at runtime when needed. Language implementers usually intend for a dynamically generated class to be logically part of the implementation of a statically generated class. Dynamically generated classes would ideally be non-discoverable. Additionally, dynamically generated classes may only be needed for a limited time, so retaining them for the lifetime of a statically generated class might increase memory footprint. Now, the current standard APIs do not differentiate whether the bytecode of the class was generated dynamically or statically. Therefore, the class will be more discoverable or have a longer life cycle. With hidden classes, we improve the efficiency when generated classes dynamically of all language implementations built on the JVM. Now, this is a feature that most developers will benefit from, but few will actually use directly. We expect it will be used by frameworks and other JVM languages. So, Foreign Memory Access API. This enhancement is back for a second release in Incubator module. It's the first enhancement that comes out of Project Panama. And it too has been targeted for JDK 16, in this case, remaining in the Incubator module. Once it's finalized, it will provide a valid alternative for Java programs that need to access memory that is not in the Java heap. Up to now, most developers use Java NIO byte buffer and SunMISC and Safe to reach foreign memory. This new API aims to offer a safer alternative with similar performance. JEPs not only introduce new functionality, we also use JEPs to perform essential maintenance, keeping tasks like removing no longer current capabilities and port. And to avoid surprising anyone, the flow is to first mark a feature as deprecated, and after a prudent time, which depends on how easy it is to migrate to an alternative and how widespread is the use of the feature, we'll remove it. With JDK 15, we disable bias locking and deprecate all of the related command line options. Bias locking is an optimization technique using the hotspot virtual machine to reduce the overhead of uncontended locking. Biasing the locks historically led to performance improvements over regular locking techniques. However, the performance gains seen in the past are far less evident today. The cost of executing atomic instructions has decreased on modern processors. Bias locking introduced a lot of very complex code, and this complexity is an impediment to making significant design changes with the synchronization subsystem. By disabling bias locking by default, while leaving the option of re-enabling it in the hands of the developer, we hope to determine if it would be reasonable to remove it in a future release. RMI activation is an obsolete part of RMI that has been optional since Java 8. This JEP does not propose deprecating any other parts of RMI. There is a small and decreasing use of RMI activation. There is no evidence of new applications being written to use RMI activation, and there is evidence that very few existing applications use it. A search of various open source code bases has revealed barely any mention of any activation-related APIs. And Oracle has not received externally generating bugs on RMI activations for several years. RMI activation, maintaining it requires continuous cost. So it can be removed without affecting the rest of RMI and does not reduce the value to developers, but it decreases the JDK's long-term maintenance costs. Finally, as you would expect, we also have removals of features that were marked as deprecated for removal in earlier releases. In this case, we're removing the Nashorn JavaScript engine, which was deprecated with JDK 11. We will also remove from future JDK versions the source code and build support for Solaris Spark, Solaris x64, and Linux Spark ports. The source code for all of these features will remain available in OpenJDK. Now, I hope you found this information useful and that you soon get to use JDK 15. I invite you to visit our Java homepage for up-to-date information and to follow us on Twitter so that you can be the first to hear news about the upcoming releases of the JDK. You can also reach us directly via email. I hear that some people still use that.